Imagine this. On a distant red planet, a spacecraft descends through the thin Martian atmosphere. Streaking across the sky like a shooting star, the dust settles. The hatch opens. A boot steps onto the red soil. It is not the first ship that has landed here. It is also not the first ship to carry humans to the red planet. This isn't just any landing on the dusty red landscape. The insignia on the arm of the spacesuit bears the distinct green-white-green of the Nigerian flag. It is 2055. Nigeria has just made history, joining the elite club of nations landing people on Mars, on its own technology, from its own territory. A monumental moment, a triumph of innovation, determination, and unity. A dream? Maybe. But an achievable future? Absolutely. Let's break down how Nigeria can go from earthbound to interplanetary. Let's dream for a minute. First of all, why does this matter? Space exploration isn't just about rockets and astronauts, or floating in zero gravity. It isn't just about flags and flexing national power. It's about curiosity, discovery, and proving what's possible. It's about innovation, education, and a shared hope for the future. A Nigerian mission to Mars wouldn't just be a technical achievement. It would be a statement. A signal that Africa is ready to take the next giant leap. Mars isn't just a destination, it's a symbol of what is possible when humanity dreams big and invests in the future. It's about inspiring a nation, fostering innovation, and leading Africa into the cosmos. How does Nigeria go from level 0 in space capability to a nation capable of landing humans on another planet? Let's break it down. To understand what Nigeria needs to do, let's think in terms of a country's level of capability, starting with level 0. A country would be effectively pre-space age, with no capability to build or launch rockets of any kind, and practically no aviation industry. Level 1 takes the first step in the right direction, gaining some ability to launch suborbital rockets, with maybe some capabilities to assemble foreign-design aircraft. Level 2 starts to put objects into space with some foreign assistance. By level 3, a country starts to acquire indigenous capabilities to design, assemble, and launch rockets to put inanimate objects into low Earth orbit. Level 4 then gets exponentially harder to attain, putting humans in low Earth orbit using domestic tech. From here, the XP points to level up start to become astronomical. By level 5, a country gains the ability to launch moon missions or deep space probes. India would be a classic example of this, with the recently launched Chandrayaan mission to the moon and the development of their Mars orbiter. Level 5 to 6 is where the big players China and the US operate, attempting to achieve the holy grail of rocketry, fully and rapidly reusable rockets. To put it into context, it has taken nearly a decade for SpaceX to go from achieving partial reusability with the Falcon 9 to attempting full reusability with Starship. Level 7 then becomes about mastering entry, descent, and landing on Mars, and preparing the groundwork for constructing the necessary infrastructure to support human life. Then levels 8, 9, and 10 become about mastering space habitation, improving propulsion technology to close the distance between Mars and Earth, and minimize the time astronauts spend in space, building Mars habitats and mastering in situ resource extraction and utilization, and eventually industrializing Mars. The scale is immensely tasking and insanely expensive. Success is far from certain, but excitement is guaranteed. Level 3, ability to design, build, and launch satellites using domestic rockets. Level 4, successfully launching humans into orbit with indigenous technology. Levels 5 to 6, deep space exploration, moon missions, and reusable rocket tech. Level 7, mastering Mars entry, descent, and landing. Levels 8 to 10, sustainable Mars habitation, in situ resource utilization, and industrialization. Right now, Nigeria could claim to sit at level 2, having the ability to operate aircraft and satellites. However, points get knocked off, way off. when you consider that Nigeria has no capability to launch suborbital rockets, and lacks the infrastructure or capability to design or assemble mass transportation, or even provide electrical power to meet the basic needs of its citizens. Basically, Nigeria sits just above level 0. That's a long way from Mars, but history has shown that when a nation is committed, progress can be exponential. Here's the thing, building a space program isn't just about building rockets, and rockets don't just build themselves. It's about creating the ecosystem that makes rocketry possible. Think of it like this. Before you can build a rocket, you need industries to supply high-grade materials. Before you have those industries, you need advanced manufacturing capabilities. And before you have those, you need a skilled workforce trained in aerospace engineering. In short, Nigeria needs to build the machine that builds the machine that builds the machine, laying the industrial and educational groundwork first. Big space programs don't happen by accident. They require political will, something that has been lacking in many countries. Take Europe. Despite their early contributions to space exploration, they fell behind because of a lack of unified vision. Meanwhile, China went from launching its first taikonaut into space in 2003 to building its own space station in just 2 decades. The lesson? A committed nation can achieve the impossible, and Nigeria will need that same fire to reach Mars. If Nigeria wants Mars, it must decide, does it want to be a passenger in history, or a driver? Let's talk money. The Apollo program cost the United States $25 billion in the 1960s, about $300 billion in today's dollars. And the US at this point was already supercharged with the World War II machine, the scientific advances from the Manhattan Project, and the start of the space race by putting their first satellite, the Explorer 1, into space by 1958. All in, more than $1 trillion was spent on getting the first humans to the moon. That's an astronomical figure. Here's the big but: Nigeria would not need to spend anywhere near that amount. Why? Because the groundwork has already been laid. The fundamental research has already been done. Instead of reinventing the wheel, Nigeria can leapfrog by adopting and adapting existing technology. If Nigeria dedicated just 1% of its GDP per year to its space program, that would be around $4 billion annually. More than enough to kickstart a domestic space industry, develop reusable launch systems, and fund human spaceflight programs over the next 30 years. To put that amount into context, the Starship program costs about $1.5 billion a year according to unofficial sources. Further funding could be drawn from other sources, say the $2 billion Ministry of Defense budget, the $1.5 billion Ministry of Power budget, or the $1.7 billion Ministry of Education budget, and then there's growth. As Nigeria's economy grows, so will its space budget, making a Mars mission not just possible, but inevitable. Okay, so let's say Nigeria really commits to this. What would the roadmap look like? The 2030s are going to be about establishing a domestic space industry, investing in aerospace manufacturing, and building Nigeria's first spaceport. Nigeria needs to leapfrog straight into reusable rockets, taking advantage of all that has been learned globally in the 2020s. Mastery in putting satellites into space regularly will prepare the stage for the next decade. The 2040s will be about developing human spaceflight capabilities, launching the first Nigerian astronauts into orbit, and sending robotic missions to Mars to test landing and in-situ resource utilization. By the end of the decade, Nigeria will have landed its first indigenous crewed mission to the moon, and made significant strides in building its own interplanetary transport system that will be required to get to Mars. The 2050s get us to the endgame. Nigeria finalizes the key milestones for its ITS and conducts several cargo missions to master unmanned trips to Mars. By 2055, Nigeria sends its first astronauts to Mars. Sounds ambitious? Well, so did everything else before it was done. Now picture this. It's 2055. 5 Nigerian astronauts board a next-gen spacecraft equipped with nuclear propulsion, cutting the travel time to Mars down to just 2 months. They exercise, perform system checks, and send messages back home as they approach the red planet. They arrive in Mars orbit and board the Mars entry vehicle, which flips belly down at hypersonic speeds and hurtles through the thin atmosphere down to the dusty red surface, then fires its engines for a controlled landing, touchdown, and just like that, Nigeria makes history. 2055 might seem far away, but progress snowballs. If Nigeria commits now, it can go from level 0 to level 8 in 3 decades. It won't be easy, it won't be cheap. But as history has shown, the impossible is just the unattempted. It will require vision, determination, and a relentless pursuit of excellence. Better late than never. Let's do it in Niger time. Success is not for sure, but excitement will be guaranteed. Dream big, act bigger, and anything is possible. If you believe Africa's future is in space, hit subscribe and pound the notification bell. Also, like the video to tell the algorithm you want more optimistic content like this. Thanks for watching, thanks for dreaming for a minute. Nigeria to Mars.